Hello everyone. Once again I'm doing something a bit different, being a bit experimental here. So somebody did recently suggest that I try some puzzle games, and I thought about puzzle games that I've enjoyed. One of my favorite puzzle games is The Incredible Machine. Definitely not only one of my favorite puzzle games, but one of my favorite games ever of all time. But this is a game that came out relatively recently. I think it came out in 2016, if I'm not mistaken. It's called Shenzhen I/O. Shenzhen being, that city in China, and I quite like it. And I thought, maybe it might be pleasant to make a video about it and just see how it goes over. So, as usual, I'm open to feedback. Please give me your opinions about how you like the video. Did you like it? Did you not like it? Was this boring, or does it actually work? Let's give it a try. So, the premise of the game, I didn't catch the intro because my recording software doesn't work too well with full screen stuff. I probably could have captured it, but basically the plot of the game is very simple. You play an electrical engineer, I guess probably an American one, who graduated from, university and discovered that electronics aren't really made in America anymore, which is true. Shenzhen, and here it says specifically, not just Shenzhen. I mean, Shenzhen is a huge city, but not just Shenzhen itself, but very specifically the Bay district is where literally, well, I've seen this figure repeated several times. Maybe it's, I don't know how accurate it is, but I've read many times, literally about 90% of all the world's electronics are manufactured in Shenzhen. Mostly in the Bay district. So basically, the story is just you decided to move here and join a company here because you wanted to build electronics, and that wasn't really a viable option in America anymore. And speaking for myself, I mean, I used to live in Silicon Valley. I can say there's very little silicon left in Silicon Valley, so I can empathize with that. Anyway, sorry, I know I talked too much. Let's go ahead and just. Let's see. So this is just a little bit of atmosphere here. The game it's not really a story-driven game. There is a story, but it's mostly just a puzzle game. But I like the atmosphere. One thing I really love about the game is the atmosphere because, it's about being an expat. It's about being somebody who's sort of emigrated to a different country and is experiencing life there as an outsider. So let's try to soak up some of the atmosphere while we're here. So we're in Shenzhen. This is allegedly a live cam, although it's actually just a still image. So the weather is light rain, temperature is 19 degrees Celsius, which is, what is that in Fahrenheit? That's like, I think close to 70 degrees Fahrenheit, so fairly comfortable. Maybe just a little bit on the cool side, but not too much. Air quality is poor, which I think is common in Shenzhen. And drone activity, I like how drone activity is actually reported in the weather report. Drone activity is moderate. So let's see, let's go ahead and take a look at the control panel. This is just basic stuff. Resolution, okay, I can't change the resolution. I'm in windowed mode for recording. I usually play full screen, but I'm doing this in windowed mode for recording. We can tweak the volume if we need to, but I think it's okay. I don't know, we'll see. Auto format code. I really hate auto formatting, but I'll leave this on for now just to see what it does. If it gets too annoying, I'll turn it off. I think in the game it's not too annoying, and then once we solve some puzzles, we can see the archives here, and this is for stuff after you've played the game for a while. So, and data sheets, yeah, so the game actually comes with a PDF file, which basically details, unfortunately, you won't see it because it's a separate PDF file, but I'll probably refer to it several times while playing the game because that's where a lot of information will come from. But let's go ahead and, the main part of the game is here in the email program called Concept Mail. So let's go ahead and get started. So, we have a welcome leader from, well, I guess that's this guy's name. His email address says leader, so I guess this is the, oh, he's the CEO. Okay, so this is Wang Yonghong, the CEO of Shenzhen Longting Electronics Company Limited. So these emails provide a lot of flavor text. I usually, when I do Let's Plays, I usually just read all the text, but considering the volume of text here, maybe that's not a good idea. So I'll kind of skim this. If you want to read it, of course, you can pause the video and read it yourself. But basically, so Mr. Young Hung is greeting us, saying, "Dear new employee, thank you for joining the company. They want to be a world-leading company in the electronics industry, blah, blah, blah. principles are diligence, connections. It's kind of a double entendre because, of course, in electronics you have to connect different electronic parts or components, but also, of course, it's about connections with other people. But, in IT, in the IT industry, there are jokes about networking. I mean, of course, networking means making computer networks, linking computers together, but there's also the other kind of networking, like career networking, where you network with people and meet people and build up your, well, today I guess you use LinkedIn, but, before LinkedIn, there was like actually going to meet people and shaking their hands and giving your business cards and stuff like that. And salubriousness. An unhealthy mind creates an inefficient design. This is a very sort of follow correct eating, correct behavior, and correct thinking. This is a little bit of an Eastern mentality, but okay, fair enough. I mean, we're in China, so let's consider the opinions of the locals. And we have an email from one of our colleagues, Carl Teskey. Carl is an expat like us. He is from the UK. So he says, welcome to southern China. It's all right, I suppose, except for the heat, smog, and lack of decent cheese here in Shenzhen. But it's still far better than any engineering gig he could have found back home in the UK. I'm assuming he ended up here for similar reasons. And indeed, we did. Here's a guy who calls himself Joe. I'm going to assume that's... I've noticed that Asian people who, have very obviously Asian names very often just pick sort of a random Western name and badge themselves with that. So this guy he's Joe. I assume his real name is probably not pronounced anything like that. But okay, so I heard our newest ace engineer is going to kick ass and take names. Am I right? You've probably heard about all me already, but I'm the product guy who loves to find amazing opportunities and make deals happen. Let's do this. He's a product manager. He's very enthusiastic. He'll be a source of interesting ideas. Here is Lily Wu. She's the vice president of product. Greetings and welcome to the team. She's a little more business-like, obviously. And then this is David P. Solomon, who's also not Chinese, but he's sort of, gone native a little bit, and he likes to use the Chinese form of his name. So, this is kind of what it's like to be in an international company. You've got obviously a lot of local people who live here, but also a lot of expatriates like yourself who, have come here because, they wanted something different. So it's an interesting mix. You've got a lot of people here who, whom you can relate to because they're also not from around here. And then you've got people like Ji Zhang. He's the chief staff engineer, your boss. I like how he says, I am the chief staff engineer, and then in parentheses, your boss, just in case you didn't know who your boss is. Well, I guess in the game you don't. I have not managed many foreign workers before, so please understand if I make a mistake here or there, and I will send your first job shortly. All right, thanks, G. So that's our welcome email. Important, read the manual. Yes. I'm probably not going to show the manual in the videos because, probably because I don't really have a good way to do that with this recording software. It was kind of, when I used to use Cam Studio, it was easy because Cam Studio just always showed what was on a certain portion of the screen, so I could just drag in a window and you'd see that window. But OBS, which is what I use now, most people use OBS now, it locks onto a single window. I mean, I guess I could just go to OBS and change the window that it's filming, but I could do it, but I probably won't unless there's something that you really need to see. I'll probably try to go without doing that, but I'll be looking at the manual myself. And here we go. This is our first puzzle. So it's a security camera, but it's a fake. So the idea is simple. It's a mock security camera. It has two blinking lights, and that's basically it. So it's not an actual security camera. It's literally just a plastic box made to look like a camera with two LEDs on it, two blinking lights. That's it. That's the whole product. So the first light blinks in a regular pattern. The second light is an internet light, so it should be blinking in a more random intermittent pattern to resemble data upload. So notice the design is partially complete already. Previous engineer quit before finishing the assignment. Note the timing diagrams and blah, 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 blah. Okay. Carl says, I'm absolutely certain you'll do better than that last person. Well, I wish that I shared your confidence in me, sir, but let's go ahead and open the CAD program. And yeah, this is the Circuit CAD program that they use here. Also, this game appears to take place in a slightly near future setting because the copyright goes to 2026 here. So anyway, so this is, I guess, the design that the other guy had. Yeah, so the other guy left us with this design here. And he wrote a comment saying, "Why is this so hard? Sad face." So yeah, so this is where we'll spend most of the game. This is the main part of the game. Obviously at the beginning it's a good idea to figure out what you're supposed to do. So this is kind of a textual description of the objective. So active and network are outputs connected to LEDs. So this circle here that says active under it, and this circle here that says network, these are connections. You know, these are connections to something that will plug into this circuit board that we're designing here. And yeah, here under the verification tab, you'll see what it actually should look like. So active is a simple output, which basically means it's not a binary. Like it doesn't. It's not digital. I mean, it's binary in the sense that it has only two levels, but it doesn't actually transmit data. It's just on or off. That's basically it. A simple output means it's just on and off, and that's it. So it seems to have a fairly regular pattern. It's low for 6 cycles, and then high for 6 cycles, and then that just seems to repeat. That seems to be, so that's very simple. Let me actually run this. So you can, if you hit the simulate button down here, it will simulate the circuit and you'll see what it does. Okay, so you can see, I haven't played this game for a while and I never played it to the end. I don't know how far we'll go with this series of videos, but I have played it, you know, I have played the first few puzzles before, so I have kind of an idea of how it works. But I want to do this kind of blind because when you're doing puzzle games like this, you know, the fun is in figuring it out, and it's not much fun if I already know exactly what to do. So I could have looked up the solutions and then said, okay, you do this and that, and then bam, done. But I thought, you know, let's actually try to solve this and kind of see what it's like with, you know, I hope that it's entertaining to watch me try to figure stuff out. If it gets really frustrating, let me know, and, you know, we'll try to work something else out. But I'm going to try and actually talk about this and go through the process of properly solving these and not just looking at the solutions. So you can see, I don't know how clearly it shows up in the video, but basically you can see the lineup here has it's a little bit brighter, like the line down here has dimmer portions. The point is that, see these red parts here? The red parts are the parts where it went wrong, where it did the wrong thing. So this active output up here is actually already working correctly. It's doing exactly the right thing. We need to make the network part do the right thing. Now, I think G, our boss, did say that the network light should be kind of random, but it's actually not really random. It's just not quite as regular as this. So this is like a simple square wave. It's a 50-50 square wave, by which I mean it has a 50% duty cycle, meaning it's off 50% of the time and on 50% of the time. This is not really random, it's just a slightly less regular pattern. So what we need to do, it's low for 3 cycles, high for 2, low for 1, high for 1. And then that just repeats. Actually, it doesn't quite repeat because here it's low for 4 cycles. So, okay, so let me stop the simulation, because we can't do anything until we stop the simulation. So over here on the right-hand side, we have our parts bin. This is where we take electronic parts that we can use. In this first puzzle, we have only one part, the MC4000 controller chip. And it's not bad, you know, it's a little microcontroller. It doesn't have much memory. One of the really annoying things about this game, like probably the biggest limiting factor of this game, is that you can't write programs that are very long. This chip here, these are 4 lines of code, and then how many more can we do? That's it. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 lines. That's it. We can have a maximum of 9 lines of code with this chip. So if we need more than that, well, can I fit a second chip on here? No, I cannot. There's not enough room here. So we can only have one chip on this part of the circuit. How do I move this around? It just occurs to me I actually don't know how to move the screen around. You can click on this to get a full screen view like that. And I don't need to move it around now because we can already see the whole part here, or the whole schematic here. But I think on later puzzles we might need to move stuff around. But okay, I'll worry about that later. So I apologize for those who haven't studied electronics or have no interest in electronics. This video probably won't be very interesting to you if you're not interested in electrical engineering and designing stuff like this. But I just find this stuff fascinating. I just really love this game because it's one of the closest experiences that I've ever had to really doing this in real life. I've done this kind of stuff for work before, and it's just... I guess I like this game because I empathize with the main character. This is actually something that I love doing, and I can understand the motivation to move halfway around the world to a foreign country just to be able to do this, because if this is your passion, then there are not a lot of places where you can do this anymore. Like I said, Silicon Valley is not really a viable option anymore. In Japan, it used to be Akihabara. Those of you who were around in the in the 1980s and were aware of stuff like that back in the 1980s. In the 1980s, Tokyo, and especially Akihabara, which is a district of Tokyo, was basically cyberpunk. That was like the global archetype of cyberpunk. But today, Akihabara is not really what it was before. Now it's mostly about anime and maid cafes and stuff like that, sort of otaku stuff. And Silicon Valley is basically about Facebook and Google. For this kind of stuff, there really is nowhere in the world that's like Shenzhen. Again, 90% of all the world's electronics come out of Shenzhen. So, anyway, sorry I'm babbling. I should get back to the game. So, this chip has 2 types of pins. So these 4 things here in the corners, these are connectors. They're pins, and you can use those to make connections to other stuff. We need to connect a P pin to this network terminal here. X is actually it's a bus. It's actually a data bus, so you can actually send numbers and things over it. That's a little more complicated. We'll get to that later. But P is just a very simple input out, just a general, I guess you'd call it GPIO pin. It's just basically it's on or off. That's it. So So we've already connected this chip physically to the network, connector here, the network terminal. So there's this, wire leading to it. So physically, we've already done all the physical work that we have to do. We just need to write a program. And one thing that does irk me a bit about this game is most of the game is about writing the software. I would have liked just a little bit more maybe of the physical wiring and configuration and stuff like that. But actually, the physical part of mostly it's just what I did. Just you drag a few parts onto the circuit board, draw a few traces, bam, done. The challenge is usually in writing the software. So I guess that's kind of true to life, because most electronic devices these days you usually just have one central chip. There's just one chip that does everything, and you just write some firmware for the chip, and that's it. That's development these days. So I guess it's kind of true to life, but I would have liked a little bit more of the physical and a little bit less of the software development, but whatever. So I guess I should write a program. So what we can do here, we can use this as a kind of a model, because this is basically doing what we need to do, except it's doing it slightly differently. So I'm going to go ahead and briefly explain the instructions here. MOV, those of you who know assembly language recognize obviously it's based on assembly language. What this does is MOV, it moves the value of 0 to P0. So P0 is this pin here, it's this connection here, and here the number 0 signifies when the output is low, meaning when the line is down here. So you're moving P to P0 to make it go low like that. Well, we need to do that here as well, because the output here also starts off low. And then SLP, that's not a real world instruction. This is a contrivance for this game. It stands for sleep. But yeah, in the real world, there's no, generally microcontrollers and microprocessors don't have a sleep command. There's not a simple way to wait. I mean, you can do an NOP, but that's something different. But yes, SLP6 just means sleep for 6 cycles, so don't do anything for 6 cycles, which makes sense because the output here needs to be low for 6 cycles. So 1, 2, 3, 4, 5, 6 processor cycles. And then 100 is, I guess, like 100%. So if you move 100 to P0, then it makes it go high like it is here. So you wait 6 cycles, you make P0 be 100, and then you wait another 6 cycles, and then you just repeat the cycle. That's it. That's how you get the square wave. So we need to do something very similar, except we need to sleep for a different number of cycles. We need to sleep here for 4 cycles. So I will say SLP4. And if we do this, you should see... Oh. No, of course you shouldn't, because I didn't put in the code to make it go high. I was going to say you should see it go high after 4 cycles, but, well, obviously it's not going to if I don't put in the code to do that. Duh. So I need to say move 100 P0. Okay, this should make it go high at some point. No? What am I doing wrong here? Let's see, let me write out a bit of the rest of the program. So after it goes high, we should sleep for 2 cycles according to this output here. So sleep for 2 cycles, and then it needs to go back down to 0. So we move 0 to P0, and then it's 0 for 1 cycle, so sleep 1. Do 100 again. Sleep for another 1 cycle. And then go back to 0, so move 0 P0. Now, you see what's happened here. My chip is already full. This chip can only store 9 lines of code. Now, in real life, when you're programming for microcontrollers like this, it's true that memory is in short supply. You can't write like programs that are gigabytes in size like most software today. But you usually get a little more than 9 lines. 9 lines is pretty constricting. But for stuff like this, it should be possible to do. I mean, stuff like this, you definitely should be doable. I mean, obviously it's possible. I mean, the puzzles in this game are all solvable. They're not impossible, so it's obviously possible to do. Let's see, what does this do now? Oh, hey, okay, it works. I don't know why it didn't work the last time that I tried it, but anyway. So it's leaving the simulation running. It's doing different iterations to try and see if that makes a difference. But for something as simple as this, it won't make a difference. So there we go. So production cost is 6 yen, which I guess is the cost of the chip that we put in. That's the cost of this MC4000 mic. Oh, actually, no, it costs 3 yen, but because there are 2 of them, it costs 6 yen total. That's why. Power usage is a little high, and lines of code. So it should have been possible for me to do this in less lines of code, allegedly. I don't know how, but okay, I'm not too worried about it right now. So that was our first puzzle, all done. Let's go back to our email program. And G writes to us and says, "Thanks for your prompt work on the blinking lights. Looks okay." So that was it. That was our first puzzle. That was, that's how it goes. That's how we do. Okay, let me check the time here. How are we doing for time? Just coming up in 24 minutes. Let's go just a little bit longer. I remember back in the day I used to make 10-minute videos. 10 minutes was a whole video, but let's do, I feel like I'm just getting started, so let's go just a little longer. Yeah. See, this is what I mean. You get, between puzzles, you get little filler text like this, or flavor text like this. This is really nice. So this is from Tilly, which I'm going to assume is, again, not her actual Chinese name. She just picked a Western-sounding name. But Tilly Liu she's our host. She runs this little mailing list for expats in Shenzhen. So I guess she's not, okay, so she's not an employee of this company. She's just, I guess we subscribe to her mailing list and she sends us emails because she manages this mailing list for foreigners who are living and working here in Shenzhen. So, today's topic, why are we in Shenzhen? Like, why are we here at all? I don't mean the immediate sense. Sure, we have some job or businessy thing to do. But what really was, I mean, this is the question that everybody asks themselves when they're thinking of moving to a foreign country. Why do I really want to go there? And even when you're there, you'll ask yourself, why did I come here? Did I make the right decision? You'll start to doubt yourself and think, was this a mistake? Was this a good idea? Should I think about leaving or should I think about staying here longer? I mean, these are serious decisions. But yeah, here again. We're here because what's possible in Shenzhen really isn't possible many other places in the world. And I would wager to say probably not any other places in the world. Certainly not at the same scale and cost. Yeah, I mean, the reason why Japan is no longer a leader in the electronics industry is because China could do it cheaper. The reason why, I mean, people sometimes wonder, why did the global electronics industry leave Akihabara in Tokyo and why did it move to Shenzhen? Well, basically it's about price. The Chinese could build parts cheaper because they have more land and more resources, and yeah, people followed the money. If you can get the same product but for cheaper, you'll buy it for cheaper, right? So that's what happened. And yeah, what is all this growth for anyway? Well, capitalism and the whole idea of infinite growth. And yes, I know infinite growth is not sustainable. Everybody knows that, and everybody's saying, well, what's next after capitalism? But as Tilly says, that's a topic for another day. Let's move on to the next puzzle. At least, I don't know if we'll finish solving this in this video, but at least let's take a look at what it is. So our factory floor has some examples of older command that require signals to be amplified. We had a device to adjust signals for the type of the machine, but it was recently broken, smashed. This is an appropriate project to teach you about inputs. Smashed? Hang on, what happened? Is everyone okay? No need to worry. Okay, well, we don't know what happened, but that's all right. Let's go ahead and open up Concept CAD and start up a new design. So here we go. Once again, we have a circuit board with two things on it. Oh, I love the music in this game, by the way. I don't think I mentioned the music yet. The music in this game is wonderful. It's very ambient, like it's kind of it's non-intrusive, which I like. I like that the music's not very intrusive, just kind of nice background music. But it's really nice. It's actually really relaxing and soothing, and kind of creates a good mood as you're scratching your head over how to build these circuits. It's really I like it very much. Okay, what are we doing here? So control in is a simple input. So this is, an input. There's some wire. You don't see the wires, but I mean, there are hidden wires that will connect to this. And this is, from somewhere there's a signal that comes into this circle here from factory equipment. And control out over here is an output connected to other factory equipment. So input, output, very simple. The signal for control in should be multiplied by 2 and copied to control out. Okay, so here we go. So here we have not just high and low, we have different levels. Okay, sorry, I was wrong. Simple inputs are not just on and off. They're basically, how would you... I guess it's more like... I guess it's analog, actually. I guess that's more a better description. Like these so-called simple inputs and outputs, they're actually analog because you can see the voltage is actually different based on the number that it's communicating. So this here, you can see this is supposed to be 25, and then this is 50. So this is twice as high as that. So it's basically like an analog input and output. And then that this X bus thing that I was talking about is more like a digital data bus. So we'll see, obviously, more of that in later puzzles. But so once again, our only available part is the MC4000 with its annoying 9 lines of code. But it has enough pins, so we can draw a trace here connecting control in to P0, and P1 goes to control out. So that's it. Once again, our wiring is done. That was the physical part of it. Now we just write the software on this chip, and hopefully it will work. So what do we need to do? We need to get the input from from here. In this case, we'll call it P0. So this chip has no idea what control in and control out is. That's not part of the chip. The chip just knows P0, X0, P1, and X1. So since control in is connected to P0, we will say move P0, take what's in P0, and can I just say P1? I'm curious, can I actually do this that directly? Oh, part not sleeping. This is a weird thing. This is one of a few weird things about this game that kind of irks me. You need to put a sleep cycle at the end of your program, or else it just waits forever for something to happen. I can't really explain. There's no real world equivalent of that. Like, there's nothing like that that actually exists in real life, so it doesn't make a lot of sense. I mean, time doesn't stop just because you didn't put an opcode on your chip. It would be really nice if you could freeze time by just not writing, one instruction on your microprocessor, but obviously real life doesn't work like that. Time will keep going regardless of how your software is written. But in the simulation, you can actually stop time by just forgetting to make the processor sleep. So, okay, so just put a sleep one, that's fine. That should, again, don't worry too much about how it works. It doesn't make a lot of sense. Just know that you have to do that in this game. Okay. So yeah, that works exactly as written. So it's literally just taking the input here and copying it to the output. It's taking P0 and transferring it to P1, just a one-to-one copy. So that's fine, but as we saw here, you need to multiply the input by 2. So it should be pretty easy to do. But for something like that, we need to make use of the accumulator. This ACC here is what's called the accumulator. And this is a real world thing. Real CPUs, real computer CPUs in real life have an accumulator, and this is exactly how you do it. This is exactly how you do it in real life. You would say not move P0 to P1, but move P0 to the accumulator. And now we can do math with the accumulator. That's exactly how it works in real life. So what's the instruction? I mean, a lot of the challenge is just remembering how the different opcodes work. I could look in the manual, but it depends on the CPU. I mean, some of them, I think MUL. Okay, it looks like it, yeah. So if your program is wrong, these buttons are grayed out. You can't run if there's a bug in your program, or if the syntax is not valid. Yeah, so it's expected to register a number. So okay, so it looks like MUL is the multiply. I'm assuming it's multiply 2. I noticed that I don't say what to multiply. So obviously when you multiply something, you need to multiply 2 things. If you say multiply by 2, okay, 2 times what? Or what times 2? But I think in this game, and also often in real life, if you say multiply, and then just specify one number, it's implicit that you want to multiply the accumulator. So this is also like real life. This is something that's actually true to life. On most computer CPUs, if you just say something like multiply 2, that means multiply the accumulator by 2. So basically the accumulator is kind of the temporary sort of scratch pad where you do math operations. You can add, multiply, subtract, divide, and usually those operations will work on the, or they will act on the accumulator inside the processor. The word accumulator is a bit of a misnomer because it doesn't necessarily accumulate things. It's just sort of the like I said, it's kind of the scratch pad. Like when you're doing math, you need scratch paper, you need a place to work. So the accumulator is the processor's scratch paper. Okay, let's simulate this. Hopefully this works. No, it does not. Okay, and the reason for that is because I forgot to output that. So I successfully multiplied the input, but I forgot to say move the accumulator to P1. Obviously, you have to have output. The whole point is to get the output out to the control output, because otherwise this thing is worthless. So let's try simulating it now. Okay, now it works. There we go. And again, it's going to go through a few different iterations, but that was pretty straightforward. So obviously these are early puzzles. Later puzzles will get much harder, like a lot harder. But there we go. And I do note that I got so I think the height of these bars indicates how many people get these solutions. So this means that most people, I basically did the solution that most people do. Interesting that there's like a little line here in front of or over the 3 that suggests to me that somebody, like a very small number of people, figured out how to do this with 3 lines of code. I'm just thinking, how would you do this with 3 lines of code? Is it possible, or am I misinterpreting that results screen? It seems like, I mean, I'm not saying it's impossible, but I'm not seeing how to do it. If you could get rid of that stupid sleep line, then it would be possible. I mean, on a real processor, you wouldn't need a sleep line. Okay, you wouldn't need sleep, but you would need a go to, like you need a jump to jump back to the beginning, so that would be the 4th line. On a real processor, you'd say, go back to the beginning and do it over again. So, okay, fair enough. I'm just trying to think if there is a way to do this with 3 lines that occurs to me, but I am not seeing any way to do that. I mean, basically, there are 3 operations that you have to do. You have to get the input, which is the 1st line. You have to do the multiplication, which is the 2nd line, and you have to do the output, which is the 3rd line. I'm not seeing a way to skip one of those steps here. And then at the end, you need the instruction that actually makes it not freeze time. So I'm not seeing a way to do it. If anybody has suggestions, go ahead and post in the comments, and we'll see if maybe we can actually get this down to 3 lines of code. That would be pretty awesome, but I'm just not seeing a way to do that. I don't know if that's possible. Anyway, I'm going to go ahead and stop the video here. Thanks for watching, everyone. Again, I hope that this was interesting in some way. I hope that it's interesting just watching me kind of puzzle over things and discuss my thinking process and, the process of reasoning through puzzles like this. Let me know what you think. I am curious to get feedback from you folks. Yeah, so this was the first couple of puzzles of Shenzhen IO. Welcome to China, everyone. We are electrical engineers in a foreign land, and I'm having a lot of fun with it. I hope you are as well. I hope that it's fun to watch. We'll see where things go from here. Again, leave your comments and suggestions and ideas, and we will see where things go from here. All right, everyone. Thanks for watching. Bye-bye for now.